So we do have a few questions in the chat, so I'll read those off for you. First question is associated with the base camp. The question's wondering when decisions might be made on where we might choose to locate the base camp. How can science help with making that base camp a reality? And are there other critical inputs that might be needed now to help make that base camp a reality?
So let me take the first one and maybe a little bit of the last one. But Jake, I look for you on the second one to weigh in a little bit there, as I'm the of the three speaking here, I'm the only non-scientist. So the base camp, and I try and share this pretty regularly. You know, if we pick a single place for a base camp, that puts some severe constraints on when we can launch. And if we miss our launch window, you know, we're going to have to wait a couple weeks to go back. And so the architecture team, and I think you all know the architecture review process we went through recently, and we're out right now you can review our architecture definition document. Picking that single place is being evaluated by that team. But what we're trying to trade is, do we just pick one place for a base camp? Do we look at the habitation elements that are in play? One of our international partners wants to provide one. We want to build one. Do we put 2 down? Do we put 3 down? So we always have a place to go to that maximizes our launch opportunities. These missions are very complex. And when you add up the mission availability for Artemis 4, for instance, for a long time, we had 0 days of availability when you looked at all the constraints that were on it. So the base camp decision, I think, probably will come in a segmented form. We might have a couple camps that we put down where we put our habitation elements. That I expect to come out of the future architecture concept reviews. The next one happens this November. So Jake, I think the second part was, how can science help inform those decisions? Let me let you answer that one.
Yeah, and I'll hop in here, Nikki, and then any thoughts that you have, be welcome to hear that as well. I think what's really important is just understanding what it is we hope to accomplish and would need from a base camp, because what the base camp is still under definition. And so, as Jim mentioned, we're in a process of assessing the architecture. And we're trying to start from the question of what is it that communities want to do, not from a position of here's what you get, and let's do the best you can with it. So part of what Jim is alluding to is, to spend more and more time on the lunar surface, we need to find ways to start reusing hardware. And so there's sort of a connectivity between some of the possible locations we could be at. So we want to make sure that assets such as the lunar terrain vehicle might be something that we could use more than one time at multiple different locations, and even use when the crew members aren't there. So these are some of the things we're taking into account right now, and then the science will help drive us. What is the science we hope to accomplish in the South Polar region? And which of those science aspects to science do we need to use a base camp? Do we need power? Do we need crew members to be living in a habitat to study biology activities such as that? So it all kind of starts with this whole process we're going through right now. And a little bit later, Najud Marency will join us to talk more specifically about the Moon to Mars objectives and the architecture definition document, the ADD. So I don't know, Nikki, if you want to add some to that about the science in particular.
I think you did a great job. I mean, it's really about what do we want to do in a base camp? Like what is that going to enable us to do on the surface of the moon? But as to how can science help with making decisions and sending in the science that submit white papers. We've talked about using the analysis groups, the MEPAG and the League. So the League in particular for this one, to actually, submit white papers. Tell us what kind of science you would want to do in a base camp. What is it that we can only do if we have a base camp that we can't do with a robotic experiment or with, a human out on the surface? What is it that you actually need in that base camp, and what science, what is driving the science in the base camp? So I encourage everybody to white papers up through particularly the league for this one.
Great, thanks, Nikki. Next question is referring to the Human Landing System demonstration mission. The question is, when might we expect the HLS demonstration mission to occur? And are there any science opportunities for any of these uncrewed landings?
I think the HLS question is a great one for Nikki. Go ahead, Nikki. I'm just kidding. Yeah, I think, we're, so first, the second part of that question, we have absolutely carved out on the uncrewed demonstration mission place for science. And Nikki and her team are evaluating what we can fly on that. I think the overall philosophy, stepping back, is we've said anytime we're landing something on the moon, crewed or uncrewed, we want science on it. So the uncrewed for both landers will have the opportunity for science on it. We're working with SpaceX on their schedule right now for the first lander for their uncrewed demo. Obviously, we need them to fly. We need them to fly frequently. They have a number of technical issues to get past, the cryogenic transfer, filling up the depot. So, we're working with them on their schedule. Their original target was sometime next year, the middle of next year. Obviously, they have challenges with that, with the first flight and just getting flying. So we'll continue to work with them and continue to work with Nikki to have those spots there for science. We've also, on every mission, carved out 450 kilograms that are for us to do what we would like to do with them. It might be logistics, depending on the need. Science certainly plays into that. So at a minimum, every time we land out of our allocation, let alone everything else that's out there, we're carving out those 450 kilograms. So Nikki, you want to add to that?
No, I mean, we're delighted. So I said no and then added, but yes, I would. So we are delighted to have all of these science opportunities. I think everybody knows we had some really great science that flew with Artemis 1. We had a lot of CubeSats that launched. We didn't have a lot of CubeSats that were successful. Sadly, we're looking at what we would need to do to make sure that they would be successful on future missions. But we had some really great biological and physical science that was done inside the Orion, and definitely planning for much more of that. And as Jim said, anytime we send something up, uncrewed or crewed, we want to make sure we're doing science. So we'll be soliciting. I think the solicitation for the science for Artemis 3 comes out next week, and we'll certainly be looking at what we can add to all of these opportunities.
Great. Well, thank you, Nikki. Thank you, Jim. We're right at the half hour here. We really appreciate, again, you giving us 30 minutes of your time to talk to the community here. There's a lot of excitement and interest in how we continue to integrate science moving forward. So we really appreciate your time and your thoughts on this. So thank you for joining us today.